Alright, for the upteenth million time, my robot is camera shy. I'm going to hit start and we're going to go. Hopefully we can pass this time. I'm running this on a virtual machine because I have a Mac. So I've seen a lot of issues with latency issues because most of my program is event driven. Just one if activity, and it just coordinates reading just shy of straight ahead. It's more or less, it's leaning towards the 92nd degree recommended by the programs in the book and by the professor and the TA. Here he's actually traversing pretty well, following the wall, following algorithm. It's going around the right side of the wall, staying as close as he can to it, and scanning constantly in front of him. As he turns, he keeps scanning more and more to gauge distances, so he knows where he's at. This type of algorithm doesn't typically work, though, if it's a bigger maze and the outside maze just has a wall that goes around the entire outside. It never gets to the inside of the maze, so for this example it works well. And the professor said we could use this. Here's what I've been calling the peninsulas, the walls that just stick out and you kind of have to go 180 degrees around them. They become very difficult because the robot gets caught on them and will flip, so I had to implement a backing up algorithm, or backing up activity, so that way he could back up and then go forward again and get around the walls. There you go, you can see him back up there. That seemed to help. Adding speed to the robot, which I wish we could do because this would be a shorter video, wasn't possible because he would run into the walls too quickly, or he wouldn't make calculations quickly enough, or wouldn't be able to capture the events in a timely manner. So this is the best of what we got right now. Hopefully this won't be longer than 8 minutes. As you can see, he's still checking it out. Sometimes in little nooks like this, he'll get a little spurt of power somehow, and that spurt of power will cause him to jump across, which could totally flip you on the wrong side of the maze. So far it looks like he's doing pretty good, though. He's going to keep getting as close as he can to that wall until he hits some threshold, and he's going to follow along it. There you go. It's actually looking pretty good right now, so hopefully the next two peninsulas won't be a doozy. This next one usually isn't a big problem. Right here, let's see if I can show you the mouse. This one is not the most difficult one, but the most difficult one is right here at the end. So he's moving along slowly, but he's doing what he should be doing. We're on 3 minutes right now. I typically like VPL, but it's extremely hard to debug, and you just have to use the quote-unquote old printf way to do it, with having a data variable and using a simple dialog box, which really stinks. I use timers a lot. It's very difficult to use the event-driven stuff. It seems like to do this kind of programming and using this kind of environment, you have to plan quite a bit ahead. If you design it correctly, then it shall work, but going off the cuff is very difficult. So here he is coming by the second peninsula in this little maze. Oop, he almost flipped there. Dangerous little mark. Hopefully he will read that he needs to back up here, or he'll keep inching around it. Oh, looks like he's probably going to inch around. He's not doing too bad right now. Just make sure he doesn't flip. Hopefully he backs up here. Come on. Don't flip, please. There we go. He backs up. See, he'll just scan around because there's big distances, so he'll do a full loop. Once he gets back in, he'll come right back to the wall. Hopefully, nope, he's not doing well. Hopefully next time around he'll do it. That may have been too much of a backup for him, but hopefully he notices that wall's... There we go. I've been calling this robot Cletus. So we'll keep going along here. And A lot of times in this area, he'll get turned around and think this is the right wall, so he skips the whole map completely, but I tried to tighten in the threshold for how close he should be to the wall, and I tried to catch the backing up to be closer to. It was a smaller threshold. I increased it a little bit so he'll back up more frequently. Right here now, he's doing pretty good because he's keeping close to that wall. Not sure why he backed up there. This is the hardest peninsula of the whole maze for me. Not sure what he's doing right now, but he must have been scanning something interesting there. Backed up, I don't know what's going on, but he's still following the right side wall, just a little slow. We're at 5 minutes, so it's actually not bad time for this maze for what I've been doing. If I could just get a spurt of speed past this thing, it'd be great. Seems he really wanted to take his time. It really stinks when you wait 6 minutes and you see him flip here. Oh, that's good actually, because he'll go around. He's recalculating and hopefully gets on the wall, and then I'll get him right around it. He sees it, and he's going to do another loop. It's good. He moves over a little bit every time he does one of those loops, just from going forward. And it looks like he's caught that wall, and now he's going to fall along it, and we now have a successful traversal. Once it gets past that line. Come on, buddy. Come on, Cletus. Still going. The code for this is fairly simplified. When I do it the other direction, which I'll try to do next, it's a lot more simple, I believe, because there's only one peninsula I have to follow. So, here it is. And we have done it. He will actually continue falling around the maze. But that is a complete traversal. And thank you for watching. Bye. This is Chris Shaw's video.